So I might have got cut off there at the end of that first video. So I'll try to speed it up just a little bit here as we finish this out. Resistance, to solve for that, we're going to separate the resistance. And again, it leaves voltage on top. And it leaves current or amperage at the bottom. And we can divide voltage divided by current. Let's kind of finish this with talking about circuits. A circuit is just a path for electricity to flow. So it's a series of conductors. You have some sort of power source, and you have loads, lights, motors, heating elements, things like that, and usually a switch to turn the circuit on and off. The current inside of the circuit flows from negative to positive. The voltage inside of the circuit flows from positive to negative. A parallel circuit, this is one that we'll build a lot of this year. It can have many devices attached to it, like many LEDs, and the LEDs will all be bright. You still have to have a power source, usually a switch, and some wiring or jumpers to connect those. Where the lights or the loads are attached on a circuit diagram looks to be in parallel lines. So a two-load parallel circuit could look like this. Here's another one that does not contain a switch. A series circuit has everything connected in one continuous line. They're all in line with each other, one after another. The downfall to this is that all of the components will each take a small amount of the voltage, and the more that you add to the circuit, the dimmer or slower, if it's a motor, the slower it'll run. So it's very simple. Everything's in one continuous path. But if you do lose an LED, you do lose a light bulb, the motor burns out, everything else will cause it to go into an open circuit where it will no longer work. So the switch is closed on the series circuit. All three of these lights will work. But if a light bulb does burn out, the rest of them will not operate. And open in electricity, it's when the electricity cannot flow from one end of the power source, the battery, or the wall plug, to the other end. Something is broken somewhere in the circuit. So if you have an open circuit and it's caused because maybe a wire got cut or a wire got nicked, you have a chance for some electrical hazards, either a shock hazard. It could cause things around the short to get warm, and we want to try to make sure when we're making connections that we avoid having opens or shorts. In a closed circuit, again, the switch is closed, the switch is pushed, the light switch is clicked up in the up position, and that means electricity can flow from one end of the power, a battery or a wall outlet, to the other side and back. Switches come in all kinds of different shapes and sizes. You got push button switches, toggle switches. We will use both of those in this class. You can also have switches that are motion sensing or are on timers that can turn a circuit on or off. And a load refers to any device in a circuit that uses the electricity. So a fan, motor, heating element, LED, light bulb. So try to think of 5 things that you have at home that are plugged into an outlet, or maybe that are in your backpack. Who knows? So to solve for voltage, we're going to again take our amperage times ohms. So if I have 15 amps, 3 ohms, 15 times 3, it's 45. To solve for amperage, I separate my amperage, which leaves me voltage over resistance. If I had 120 volts in my house wiring here, and then divided it by 5 ohms, I'd have 24 amps of current. Some of the sources I used, SparkFun's a great one. They have lots of components, electrical components. You can really read on SparkFun a long time. There's a lot of digital electronics items that are on there. And again, use the Merriam-Webster dictionary for some of those definitions of voltage, amperage, and ohms. And I've also looked at Southwire, who makes electrical conductors, talking about voltage drops, and they have a calculator to calculate the size of wire that's needed for certain lengths of run based on the voltage and the current that needs to be going through that circuit. Thanks for watching.